Hello and welcome. This is Scott Shepard, and in this video we are going to continue to solve the test 1 from fresherlives.com. You will have the link in the description, so let us proceed. We are at question 11, so let's continue. Okay, in which header files is the null macro defined? Well, definitely stdio.hash it is defined, but I'm not so sure about the other ones. This question is a little bit stupid because honestly, you don't have to know where are all the macros defined. In most of the embedded systems applications, when you write C code, you will have your own your own header files. Sorry, you will have your own header files. You will define your own source code, so you will have control pretty much about where a certain macro is defined. I will say stadio.hash, but also standard definitions may also be here. I do not know about math.hash, but I will check this one. Okay, 12. What do the following declarations signify? Okay, so this is the classic pointer declaration. Okay, we have the pointer name, and there is a CR is a pointer to a char. Okay, so a char is a pointer to a char. This is easy. 13. Declare the following statement: a pointer to an array of 3 chars. Pointer to an array 3 chars. Pointer to an array of 3 chars. Okay, when you have something like this, you have to isolate the pointer. Okay, so isolating the pointer means the pointer is in braces. Okay, in this case, this is it. This one here, I believe, is a mistake. Okay. This one here, the first one, A to say that. This one means, I don't know what really means this one, but definitely a pointer to an array of 3 chars is this one. Okay, as the first one is an array of pointers, of 3 pointers to functions that return chars. So this one here is an array of an array of pointers to functions that return char. Okay, the second one, I believe it is the same. The third one I believe is a mistake, and something like this could not compile. If the asterisk will be before, so before braces, it will means that PTR is a pointer to an array of char pointers. Okay, but in this case it will be this one. So a pointer to an array of chars. We isolate the pointer, an array of 3 chars. Yeah. Okay. 14. What do the following declarations signify? Well, this is simple. We have f. F is, in this case, the name of the function that return a pointer to an integer, and it gets no arguments. So f is a function returning pointer to an int. What will be the output of the program? Okay. 15. Okay, so we have missing library. So it could means that we get here an error because we do not have the library. So printf is not defined, or we will get a redefined. But let's suppose that he forgot to put the library. Okay, so we have um, I is an integer that is initialized with 3. G is a pointer to an integer. K is an integer that is not initialized. G is initialized with the address of I. Okay, so what we have here, we have I multiplied by with the referencing the G pointer, so it will be I multiplied with, yeah, have the workspace. It will be this line here, it will be 3 multiplied dereferencing G. Dereferencing the pointer means that we will get the value that it's stored at the address the pointer indicates to. So it's also 3. Or multiplied by 3 again, plus, again, dereferencing the pointer, plus 3, sorry, plus 3. Dereferencing the pointer, will we get the value that is stored at the address that the pointer indicates to. Okay, so we have 3, 3, 3, so this will be 27 plus 3 is 30. Okay, what will be the output of the next program in Turbo C? I don't like this because there may be things that are specific to this compiler. I don't like this kind of questions, and I believe that they should not be put in programming interview questions. Okay, so we include the studio. We have this a function. We have here a function that receive a pointer to an integer. F is a pointer to an integer. Then address of that pointer, the address that the pointer indicates to, we put the value 10, and we return 0. So in main we have an array of 5 chars, an array of 5 constant integers, and we initialize them, of course, before modification. Okay, so we print what we have at the address. We print the third element in our array. So the third element is 4. So 4 will be printed, and we call this function, and we pass the address of the third argument of the third element, fourth element. Okay, is numbering in arrays start with 0. Okay, so we pass the address of 4 to this function, and we put 10 at that address. What concerns me is that this array is a constant. So you'll be trying to modify constant. Let's try to see if this works on a compiler, because I have concern about this. You have a constant array, so you modify it. This could not work. Why? Why do you let me? Why did I ever put const here in the first place? What if I try to do this? Let's put const again. Okay. 4 equals 3. Okay. So I get an error if I try to modify it but by using a pointer I can modify that address. Yeah, this is interesting. This is very interesting. I don't like this behavior. I mean, these locations here should be read-only. Why can I modify them through a pointer? Okay, so in this case it will be this one, but this makes no sense. I mean, I have here these 5 elements. This array should be read-only. I can modify them through a pointer. Yeah. Okay. 17. Yeah, I have concern about this. What I'm going to do is I will try this later on my PC to see if the compiler on my PC behaves the same way. Okay, 17. What will be the output of the program? You can also try to on your computer to see if this code here, the code from the question 16, behaves the same. I mean, you get a 4 and a 3. Because it shouldn't, from my point of view, it shouldn't. Okay. Okay. Let's go to the 70. What will be the output of the program? So include. We have here a string, so an array of characters. Because in C we do not have the type string, we have array of characters. Okay. We have here a pointer. Also P here is a constant pointer to a char, yeah, because the const is after the asterisk. So P is a constant pointer to a char, okay, and it is initialized with the address of the first element in str, okay, in this array. The name of an array is a pointer to the first element of its from its elements. Yeah. So str here, it's the address of the hash. Okay. And we put at the address of the hash, we put uppercase M. Printf %s will print the string, will print all the elements until the end of string character will be found, termination character, which is \0. Okay, so what will be the print of this? This will print mellow, because we at the address of hash we put the character M. Okay, mellow with M, with uppercase M. So we do not have here. So I will be tempted to put none of the above because we have M, uppercase M. But I will put mellow because I believe it is it is a mistake from those who wrote this test. Okay, the operator used to give value at address stored in a pointer variable is, okay, the referencing. So the referencing is asterisk. Using this one, you can write or get the value that it is that can be found at the address in which pointer points indicates. Can you combine the following two statements into one? So we have the declaration of a pointer to a char, and here p, the pointer to a char, will point to what this function malloc will allocate in heap memory. So this is dynamically allocation of the memory. Will allocate 100 bytes, so 100 chars to say that, okay, in memory, and it will return a pointer. This one here is the type modifier, yeah, and it will malloc will return to us a pointer to this memory, to the location memory that was dynamically allocated, okay, but we format this one to be a pointer to a char, yeah, because p is a pointer to a char, right? Okay, let's try the first one. No, because this I do not think it will compile, because malloc already said that already malloc is already a function that returns returns a pointer to the newly memory location that was dynamically allocated. Oh, and yeah, definitely we do not have a pointer here, right? Okay, pointer p, char is a pointer, p is a pointer to char. I believe this one is okay. Yeah, I believe this one is okay. The other one no, because we need a pointer to a char. And this one is definitely something wrong with this. So I believe this one. Okay, the last question, 20. What would be the output of the program? Constant char s. Okay, so we have a pointer s to a constant char, and we initialize it with nothing. Okay, and after that we declare str being an array of characters in which we put the word hello. S is now initialized, points to to the newly created array. This one is legal because the pointer itself is not constant, yeah, so the pointer can point to other variables. Okay, we should have here, definitely we should have here a warning, because str is not constant, right? Okay, while s while underscore while dereferencing s ampersand ampersand star s means that we will get what the value from the location that s points to. Okay, so this while will execute until we will have the termination. We will get to the termination character of the string. Okay, So this one, what we'll do, and after that we increment the pointer. So the pointer will first here to say that in this line of code, the pointer s points to the character hash. It prints the hash, and after that it increments. Okay, so it will print to e, it prints the a and will increment. L will print it and then increment. The other L will print it and then increment. The O will print it and then increment. And after this incrementation, it will get to the termination character, and then we will exit from this while loop. So I believe it will be the same as above. It is not hello with the uppercase hash in the front. It is hello with lowercase hash. Okay, let's see how we did. Okay, 10 out of 30. Not bad, not terrible. Let's see. Okay. Oh, so we have a lot of the libraries in which null is defined. Okay, this one is simple. This one again. This one again. Again, simple. Okay, here we have some explanations, but yeah, I do not know really how this. I will make another video. At the end of this video, I will put this program to execute it on my compiler, so to see if it works the same. Okay, 17. Yeah, 18 is okay. 19 again. 20. Yeah. So here we have the explanation. Okay. So pretty much that's it. I hope you enjoyed. I will put at the end of this video the result about what happens when I execute the code from question 16 on my computer, and we will see you to the next video. Okay, bye bye. Okay, so I put the code from the question 16 on my computer and I run it, and guess what? Before and after modification 10. And after that, I read a little bit and I discovered that it is possible to modify a constant variable if you pass a pointer, a non-constant pointer to that variable, and you modify that variable through that pointer. In our case here, we should have, no, I do not have any warning. Let us compile it again. No warning. Okay. But in our case, as you see here, we have a constant array of 5 integers, and we pass the address of the fourth element to this function. The address, it is put in this pointer here in f, and through f we are modifying the value that can be found at that address. Okay, so it is possible. If we will have here also const, we will not be able to do this. But because we are able to do this. So we have an error here. Okay. Pretty much that's it.